So in this lecture we will discuss another type of problem, that is when 0 comes in the first column of truth table. What will we do when 0 comes in the first column of truth table? So that type of a problem we will discuss in this lecture. So determine the stability of the system represented by the characteristic equation s raised to 5 plus s raised to 4 plus 2s cube plus 2s square plus 3s plus 5 equal to 0. So in this problem the first step is to form the root table. So in order to form the root table you have to form the rows starting from the highest power of s, that is starting from s raised to 5, s raised to 4, s raised to 3, then s square, s raised to 1, s raised to 0. Now what is the power of s raised to 5? That is 1. Coefficient of s raised to 5 is 1. So that will be your first element. Now take the alternative elements, that is the coefficient of s cube, it is 2. Now the coefficient of s raised to 1, that is 3. Now find the coefficient of s raised to 4 from the question, that is again 1. Now coefficient of s square, now you have to take the alternative terms, so coefficient of s square, that is again 2, and coefficient of s raised to 0, that is given as 5. Now we have to find the coefficient of s cube, that is we have to find this row corresponding to s cube. So how can you do that? In order to find the value here you have to multiply 1 into 2 minus 1 into 2 divided by 1. So you will get that as 0. So we are doing corresponding to this row s cube. So we will get that value as 0. 1 into this 2 minus 1 into 2 divided by 1, that we will get as 0. Now we can find the next element in corresponding to the row s cube, that is 1 into 3 minus 1 into 5 divided by 1. So that will be 3 minus 5 divided by 1, that will be minus 2. In corresponding to this element we know that here there are only 3 columns, so this element will be 0. So here we got 0 in the first column. So what will we do when we got 0 in the first column? So when we got an element of first column only as 0, you have to replace this 0 as epsilon. Replace the 0 as epsilon, where we are taking epsilon as a very small positive number. Okay, we are taking epsilon as a very small positive number, so we can replace the 0 by epsilon. So I will rewrite the root table by replacing 0 with epsilon. So rows are s raised to 5, s raised to 4, s raised to 3, s square, now s raised to 1 and s raised to 0. So first we can write the same rows corresponding to s raised to 5, that is 1, 2, 3, and corresponding to s raised to 4, that is again 1, 2 and 5. Corresponding to s raised to 3, we got first element as 0. Now we are replacing this 0 by a very small positive value epsilon. Now the next element is minus 2 and next element is 0. Now we have to find the value, the element corresponding to s square. So how can we find? That is epsilon into 2 minus of minus 2 into 1 divided by epsilon. So what will be that? That is 2 epsilon. Epsilon into 2 will be 2 epsilon minus of minus 2 into 1. So that will be plus 2 divided by epsilon. That will be our first element corresponding to the row s square. Now we can find the next element. So what will be our next element? Epsilon into 5 minus 1 into 0 divided by epsilon. So what will be that? 5 epsilon by epsilon, that we will get as 5 only. 5 epsilon by epsilon, that we will get as 5. Now no need to find the next element. It will be equal to 0 because here there are no fourth columns. There are only up to 3 columns. So this element will be 0. So no need to write that. Now we can find the values or elements corresponding to s raised to 1. So that will be, that I will do here, the value corresponding to s raised to 1. The first value corresponding to s raised to 1. Okay, that will be 2 epsilon plus 2 by epsilon into minus 2 minus 5 epsilon divided by 2 epsilon plus 2 by epsilon. Okay, 2 epsilon into 2 epsilon plus 2 by epsilon. So this element into this element into this one minus 5 into this epsilon divided by 2 epsilon plus 2 by epsilon. So by opening this bracket, we will get the first element as by opening this bracket we will get the first element as, that is corresponding to s raised to 1. By opening this bracket and taking the reciprocal of denominator and multiplying it, we will get corresponding to s raised to 1, the element is minus of 5 epsilon square plus 4 epsilon plus 4 divided by 2 epsilon plus 2. And the next element will be, we have the next corresponding to this element, that is this one. We have 2 epsilon plus 2 into epsilon into 0 minus epsilon into here also 0. So this element will be 0 because this element is 2 epsilon plus 2 by epsilon into 0 minus epsilon into, here there is no element, that means the value here is 0. So the next element will be automatically 0. Now we have to find the coefficient corresponding to s raised to 0. So what will be that? That is this element into 5 minus this one into 0 divided by this. So we will get the value as 5 itself, because that will be minus 5 epsilon square plus 4 epsilon plus 4 by 2 epsilon plus 2, that is this one, into plus 5 minus this one into this, that will be equal to 0, divided by this. So you will get the value as 5. So now we got the first, we have completed the root table. We have completed the root table now. Now what we have to do is, we have to find the values of this first column of the root table by letting epsilon to 0. So we are assuming the value as epsilon value is very small positive number. So we are letting epsilon to 0. So it will be, what will be 2 epsilon plus 2 by epsilon when you let epsilon to 0, or when you apply the limit epsilon tending to 0, this value will be 2 into 0 plus 2 by 0. So this will be plus infinity, because we are letting epsilon, as we are taking epsilon as a small positive value and we are letting it, applying the limit, we are letting it to 0. So this will be plus infinity. And what will be the next value? That is minus of 5 epsilon square plus 4 epsilon plus 4 by 2 epsilon plus 2. That will be equal to, when you apply the limit, it will be equal to minus 4 by 2, that will be equal to minus 2. So now we got all the values of the root table. Now we can rewrite the root table as, now the next step is to rewrite the root table by applying the limit epsilon tend to 0. So here we can see that when we take the first column, here we can see that there are two sign changes in the first column, because that is changes from plus infinity to minus 2 and minus 2 to plus 5. So here there are two sign changes in the first column of the root table. Hence, two poles are lying in RHP, that is right hand side of S plane, and when any one of the poles are lying in the right hand side of S plane, the system will be unstable. The system is unstable. So when it comes, when the first column, if an element in the first column of the root table is 0, when you got an element of first column of the root table is 0, you have to replace it by a very small positive number epsilon, and instead of 0 you can substitute as the value epsilon and find or complete the root table by substituting epsilon. After that you have to apply the limit epsilon tends to 0 and find if there are any sign changes in the first column of root table. So if there are sign changes, that means the system is unstable. If there is no sign change and all elements are positive, then we can say that the system is stable. So here in this question we have got two sign changes and the system is unstable. Thank you.